Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, how do atomic line spectrum give rise to the light emitted from fluorescent light bulb, right? Fluorescent bulbs. Okay, so for this question, taking a look at the book here, you will see that there are different type of wavelengths. Some of them are in a visible light, which is what we can see, and some are in ultraviolet, gamma ray, X-ray. Those are beyond the higher energy level. We can't see that, or below that infrared, microwave, or radio wave, which we can't really see that. Okay, atomic spectrum is pretty much basically the energy or the energy that's emitted different wavelengths by these elements when they're excited and then when they go back down. Now, some of them, like I said in earlier, it could be visible or it could be beyond the visible range. Now, for this question, you would need to take a look at page 172, I believe. Let me see. No, it's not. It's a little bit further down. Oh yeah, sorry. At the end of the book, it's talk about fluorescence light and how does it have to do with atomic spectrum. And then in there, it was talking about how fluorescent light has a different variation. And then in this place, it's talk about higher energy electron transferring photons. And then they were saying about something about photon emitting in two different regions, one in the visible range, but most of them are in ultraviolet range, which we cannot see. To make it able to seeable, they actually coated the fluorescent light bulb inside so that it will absorb some of the light so that we were able to see the energy, the a little bit lower energy level, which is a visible light. So that's fluorescent light bulbs. So for the idea to be explaining about the wavelengths and visible range and photon, it has to do with this. So we have an atoms, which is in the middle, would have protons, right? Protons P plus, and some neutron, which is an N0, which means they have no charge. So pretty much my center of the element has positive charge because of the proton. And then we said that they have all these different energy levels as we were talking about. Now, I'm not really drawing that in scales. In scales, if I were to draw that in scales, it probably looks something like this. The energy spectrum is a little bit variation of sizes. So it probably look something like this, and then as they come down, it's gonna be less, basically. So what happened is when the electron, I want to quickly draw that here. Electron usually fill the lower energy level first, and then and then they kind of keep filling it. So at some point, what happened was the electron will absorb energy level. So like this is when the current go through and stuff like that, right? Electron will get energy level, and what happened was these electron would jump to the higher energy level, wherever that might have been. So they would jump to the higher energy level. But the thing with it is these electrons cannot stay in that level for very long. So what's going to happen is they will fall back down to their ground state. And then as they fall back down, what's going to happen is they're going to emit this energy difference as something called photon. Okay. And then, so if these photons are the range that is visible for us to see, visible region, then we will see this. Or if these photons are really high energy level, then we won't be able to see. Or if they're low energy level, we won't be able to see because they will be at the infrared radiation level. So to answer this question, we just need to go to here, talk about in the sense of this. Okay, so electron collided. So what is happening is currents. When the current go through, right, the electrons will get into the excited electron will move into higher energy orbit level. So that's the first step. So current, excited electron, higher energy level. Now these excited electron will fall back to ground state. That's going to release photon. Now, some of the photon will be in the visible range, some of them in ultraviolet range. So that's what it is supposed to be. All right, so for this question, let me just write it down as the answers as to what's happening. So current as current flow, right? Electrons are excited and move to higher energy level. Move to higher energy level, right? And then as I had excited, I would say, electron move back into their ground state. They release photons. So think about photon like energy, basically, right? And then some photons are in visible range, some are in UV range. So in a sense of our fluorescent light bulb, there is some coating to it that will absorb some of the high energy from the UV range and then give us more visible spectrum. So that's pretty much the case for this question. It has to do with this photon releasing. And of course, depending on different elements, these level that I'm trying to draw is a slightly different, and that's going to create a different photons. All right, so that's pretty much what it is about it. Now, if you look in here for the answer, you will see that they talk about something about lowest and occupied. So that's ground state. Highest occupied, that's the excited state. So that's pretty much what it's saying. All right, happy studying.